All right, so this lesson is on solving exponential equations, which we've done before with common bases. But these equations you won't be able to make common bases out of. So instead you have to solve them with logarithms and your calculator. So I'm going to show you with Desmos how we're going to do this. Okay, so if using a common base is not possible, then this is how we're going to solve it. We're going to isolate the exponential equation. Now, we're going to write it as a logarithm. So rather than say take the logarithm, we're going to write as a logarithm. And then we're going to solve it from there. And again, the extraneous solutions, because it's an exponential equation, the variable can be anything. It can be positive, negative, and so on of the numbers. So we don't have to worry about the extra solutions here for exponential because the domain is all real numbers. All right, 3 to the x equals 80. There is no common base that we could use to solve this. So instead, we're going to write this as a logarithm. So if I write this as a logarithm, the exponent is x, and the logarithm will have a base of 3, and inside will be 80. So that's writing it as a logarithm. We're going to change the base. So it says log 80 divided by log 3. This way we can use our calculator to evaluate it, and that's it. That's going to be the answer. So let's go to Desmos. Now, when you go to Desmos, you're going to have to click on the keyboard. Just move this quick. Click on the keyboard. There it is. Click on Functions. Click on Miscellaneous. And then you'll see log here. So type in log, and it's log 80. Move the cursor. Divided by, so /, and then same thing, log. And in the is what? Log 3. Now I know the answer is going to be close to 4, which it is, because 3 to the exponent 4 is 81. So it's really close to 4. So it's 3.989. And you have your answer. All right, let's solve this equation. E to the x equals 140. So we're going to solve this writing it as a logarithm. The exponent is x. The logarithm that has a base of e is called ln, and then inside is 140. And that's it. X is already by itself. Just type that in your calculator, and you have the answer. So I'll get rid of that. Again, if you go to Functions, you can see ln right there. So go ln and then go 140. And you have 4.941. Actually 4.2, right? If you round it. All right, let's keep going. I want to solve this. The bases cannot be made the same. So I'm going to write this as a logarithm. The exponent is x plus 1. The logarithm has a base of 5, and 18 is inside it. Subtract 1, and then use your calculator. That's it. So let's type that in correctly. So in order to use your calculator again, you have to change the base. So it's going to be log 18, move the cursor, divided by log 5. So there, and then move the cursor and subtract 1. And it's done. So the answer there is 0.796. So whenever I see a logarithm and I put it in the calculator, I just know it's log 18 divided by log 5. That's how you do it. All right, number 4. Can you write this as a logarithm? So that's 2x subtract 5 equals the base of the logarithm's 1/3. Inside is 120. The calculator doesn't care that it's 1/3 and 120. I still need to work to get x by itself. So I'm going to add 5. And then after I add 5, I'm going to divide everything by 2. So that's what I'm going to put in my calculator, this right here. So I'll help you through that, how to put that in your calculator. So I'm going to start with the divide sign. So in the numerator is going to be log. You can just type the letters in, log. So log 1/3. Don't put in 0.3. Move the cursor. Divided by log 120. Wait a second. Sorry, 120, then 1/3. Make sure I do it right. So log 120 in the denominator is log 1/3. This is still in the numerator. So log 120 divided by log 1/3 plus 5. And then in the denominator it will be 2. And that's it. So practice using it. You still need some skill to use a calculator. Double checking the answer key, 0.321, which I like. It's a nice number. And there it is. So it's 0.321. All right, let's look at number 5 together here. So in this situation, the exponential is not isolated yet. So we need the exponential isolated, and then we can write it as a logarithm. So first I have to subtract 25. That's a good first step. So 108 subtract 25. That's 3 and 8. That's 83. Then I can now write it as a logarithm. So we have 3x. The logarithm with the base of e is ln. And then it's ln 83. And then divide by 3 and use your calculator. So again, you can just go ln. So just type in ln 83. Oops, almost lost that. And then divided by 3. Done. So you can type in the letters in Desmos. You don't even have to find the symbols. Make sure that's correct. 1.473. So there's the answer. You might recognize that I do a wavy equal sign. That's a symbol for approximate. So it's not equal, it's approximately that. Number 6, step 1 is to isolate the exponential part. So when I look here, the exponential part is 8 to the exponent 4 subtract x. So I'm going to divide by -2. Now, a situation where you would have an extraneous solution is if you have an exponential equaling a negative number. So that is a situation that can't happen. So the exponent can be any number, but if you have an exponential equaling a negative number, that's impossible. That's no solution. All right, but this is good. This is an exponential equaling a positive number. Write this as a logarithm. So 4 subtract x, and the logarithm has a base of 8 and 25. To get x by itself, what would be the easiest? You know what would be the easiest? We could add x to the right and then subtract the logarithm to the other side. And then type that in. So I added x and subtracted the logarithm. Now I have my solution. And now I'll use the calculator. So I'm going to type in 4 subtract, and it's log 25 divided by log 8. So that's simple to type in that way to get the logarithm, and it's 2.452. So 2.452. All right, turn the page. These will get a little bit more complicated, but we're going to do it together. I think you get the idea that it's a simple lesson. So step 1 is to identify the exponential and isolate it. So step 1 to do that is to add 1. That's 42. To undo a fraction, you do the reciprocal. So the reciprocal would be 3 over 2. So again, to undo 2/3, you do the reciprocal to both sides. So the 3's and the 2's, they divide out. Now the exponential is isolated. On this side, you have to divide and multiply. So 2 goes into 42 21 times, and then 21 times 3 is 63. So I divide and then multiply by 3. Now I can write this as a logarithm. So the exponent, x subtract 6, the logarithm has a base of 2 and goes inside as 63. And then the last step to get x by itself is we add 6 to both sides. And now we're ready to use our calculator. So we have log, what do we have? 63 divided by log 2. And then to that, we add 6. So that's 11.977. Keep going. Number 8. So again, identify the exponential part. And then how do I isolate it? So I'm going to subtract 9. That's negative 64. Then I'm going to divide by negative 2. This is important that a negative divided by negative, 30 divided by 2, 32. All right, so a negative divided by negative is positive 32, or else there'd be no solution. Now write it as a logarithm. So the exponent, 2x plus 7, the base of the logarithm, and then 32. To get x by itself, subtract 7. And then divide everything by 2. So that's what I'm going to type in. So I'm going to start with, let's just get rid of that. So I'll start with the divide sign because I have a numerator and denominator. I'm going to type in log 32 divided by log 4. Move the cursor, subtract 7. And then in the denominator is 2, and my answer is negative 2.25. We actually could have made it, we could have made common bases here. So because the answer is not irrational. Irrational is a decimal that goes on forever and doesn't repeat. Because it's just negative 2.25. For number 8, you could have made common bases and not use a logarithm. So it always works to use logarithms. It only sometimes works to make common bases. Number 9. This one, clearly you cannot make the bases the same. This is the next level of difficulty. So we have variables on both sides and exponents on both sides. You have to make a choice. And I'm telling you, the choice should be pick the exponent that's more complicated, and we're going to change that to a logarithm. So the more complicated one here, they're both pretty equal. I'm going to pick and make a choice. So I'm going to take what's on the left and use it to write a logarithm. So we have the exponent x plus 5. We have the base, which is 2, and then what goes inside the logarithm is 3 to the exponent x minus 2. Next, we're going to use some properties because our goal is to isolate the x. So we have x plus 5, and then the property we're going to use is if we have an exponent raised to another exponent, you multiply the exponents together. Now, remember that log 3 base 2 is just a number, like 5 or 8 or 8.1, whatever. You can distribute that number to remove the parentheses. So that's x times log 3 base 2, and then distribute. Now, I want to gather all the x's together. So to do that, I'm going to subtract x and that logarithm. And if it doesn't have an x, it's going to go on the other side. So I'm going to subtract 5 to the other side. Next, I'm going to factor an x out. This is the most complicated scenario. And then the last step, and then we'll use a calculator, is we're going to divide. All right, so there's the exact answer. Now we're going to use our calculator to type that in. So let me type that in. Start with a fraction. Then it's -2. And to type the logarithm in, you go log 3 divided by log 2. Move the cursor. Subtract 5. Now in the denominator, we have a logarithm. So it's 1 subtract. And again, it's log 3 divided by log 2. So just take your time and type it in. Don't let it be complicated. And you have your answer, which is 13.967. So again, this is the most complicated thing, but we're doing it together. And if you take your time, I know you can do it. So 13.967. And you have your answer. So let's practice again. That's how we'll get better. So number 10. You cannot make common bases. We have variables on both sides. That's what makes it complicated. I look at the exponent that's more complicated. And 2x subtract 1 is a little more complicated. So we're going to go 2x subtract 1, and we're going to write it as a logarithm. The base is 8, and what goes inside the logarithm is 5 to the exponent x plus 3. We're then going to use the power property. So that x plus 3 is going to multiply in front of the logarithm. Recognize that log 5 base 8 is just a number, so you can distribute. So just put them beside each other when you're multiplying. Don't make it difficult. We're going to gather the x's together. So we're going to subtract x log 5 base 8. We're going to add 1 to the other side. And then we're going to factor an x out. The last step is to divide to get x by itself. So we have 3 log 5 base 8 plus 1. We have 2 subtract log 5 base 8 on the bottom. And then this is what we're going to then type in the calculator to get our answer. So we're going to start with the divide sign. And then in the numerator it would be 3 log, and it's log 5 divided by log 8. And then we have plus 1. In the denominator, we have 2 subtract log 5 divided by log 8. So there it is. And you get the answer 2.709. Really, if you want to round it properly to 3, we'd write 2.710 if you want to round correctly. So that's if you round correctly to 3 decimal places. All right, there's 2 left. Let's just 2 more to practice. I know the last ones are challenging. So which one is more complicated in the exponent? It's 3x plus 2. So we write down 3x plus 2. We write down it's a logarithm. The base of that is 11. And then inside is 4 to the exponent x subtract 3. We'd use the power property. So the x subtract 3 is multiplying in front. Next we distribute. So when we distribute, it'll be x times log 4 base 11. Subtract 3, and the same thing here. So we distribute, just put them beside each other. We're going to gather the x's together. So we're going to subtract x log, it's 4 base 11, and we're going to subtract 12 to the other side. The last step here is we're going to factor out an x and divide. So factor out that x and divide. This is good algebra skills, right? To be able to isolate the x. And then the last step is to divide it. So that's what it looks like when you divide it. That's what you're going to type in the calculator to get your answer for x. So be patient and work your way through it. So it's start with the divide sign. So it's negative 3 log, and it's log 4 divided by log 11. Move the cursor, subtract 12. In the denominator is 3 subtract log 4 divided by log 11. That's it. And you get negative 5.671. All right, we have one left to do. So there's the answer right there. And we have one left to do. So let's do it together here. So again, the more complicated one, I would say, is the right side. So it's 5x plus 4. You get the right answer either way, but it's a little easier if you take the more complicated exponent. And then we're going to write it as a logarithm. So it's 9 to the exponent, what, negative 2x. Next, we're going to use the power property. And then we're going to distribute. So when we practice, we're doing the same technique kind of over and over again. We're going to distribute. So that's negative 2x. And that's it, right? Yep. Actually, I didn't. I just rewrote the same thing twice. That's just being silly. Gather the x's together. So we're going to add 2x and the logarithm to the other side. We're going to subtract 4. And then the last step, we're going to factor and divide. So factor out an x, and you have 5 plus 2, and then divide. And it's done. Use your calculator. So if I want to type that in, start with the divide sign. Negative 4 in the denominator is 5 plus 2. Oops. 5 plus 2. And it's log 9 divided by log 2. And you have your answer. And that's negative 0.353. And there's your answer. Yep, there it is. Negative 0.353. So by practicing and having some confidence, not giving up, you get it. So Mr. G Math over and out. Until next time.